So today we're going to talk about problem solving, and we're going to be talking about some real world problems. Now, the people on the video couldn't see me, and most of you guys couldn't see me because you weren't looking at me, but that's okay, I'm not mad. What I said was real world problems with air quotes, okay? Because in the past, I've given out this worksheet and people are like, these are not real world problems, I'm never going to do this. Okay, well you might not, but might other people do it? So it's not real if it's not real to you? Is that what you're telling me? No, these are real world problem situations, okay? But before we get into that, we need to talk about the discriminant, okay? Now, you guys know what a discriminant is. I haven't given it the name before, but as soon as I write it down, you're going to know what it is, okay? The discriminant is this. Have you ever seen that before?
Yes.
Yes, where? In our song, right? What's the song called? Quadratic formula. We need to make sure we remember it because it's been a long break. Yes, absolutely. I would love to sing it. Okay, ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I don't think we were all the way warmed up yet because I didn't hear everyone. Okay, you ready? Let's all sing it now that we're all warmed up. Okay, ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What is it for? Don't tell me what it's called. Tell me what it's for. Solving quadratics. Yeah, that's exactly right. I know it's called the quadratic formula, and I'm glad you know that it's called the quadratic formula, but I need to make sure you know what it's for. Okay? Now, do you remember singing this part of it? B squared minus 4ac. This is the discriminant. Okay? Now, notice that we didn't sing the square root of b squared minus 4ac, right? Discriminant is only b squared minus 4ac. Are you okay with that? It's what's inside the square root sign. Here's what I need you to know about the discriminant. Okay? If we do, we can actually know how many solutions that a quadratic has just by looking at the discriminant. Okay? I'm going to write this down so we can talk about it real quick. Quadratic formula, right? This is what's inside the root sign. So without having any problem or numbers or situations, I want you to be able to tell me what happens, how many solutions, if my discriminant is positive. Well, if that's a positive number, I can take the square root of it and get how many answers? 2, right? The plus or minus. So how many solutions will I get? 2 real solutions. Right? What's another possibility that b squared minus 4ac could be? Oh, we'll do that one in a second. What's the other possibility? It could be 0. Okay? What if it's 0? Try one more time. 1 real solution, right? Remember this one's called a double root? You remember that? And what's the other possibility? Negative. We're going to write 2 things right here, so be ready for that. How many solutions do you have if this is negative? How many real solutions do you have if what's underneath the square root sign is negative? 0. No real solutions. How many solutions are there, though? 2, how many? Or 2 kind? What kind? No, there's 2, right? They're imaginary, though, right? 2 imaginary solutions. But our concern right now is the real ones. Okay? Because here's the thing. Here's the problem we're going to talk about first. There's a plane flying right here. Thanks. That plane is flying at 2,100 meters above the ground. Okay? There's this little guy right down here with a missile launcher. I know it looks like a cannon. Just get over it. I don't know how to draw missile launchers. So we're going to pretend it's a missile launcher that looks like a cannon. You okay with that? So here's the thing. This guy doesn't like this guy. And he wants to shoot down the plane. I know it's not very nice, but it happens in real life, right? Does this happen in real life?
It could. Somewhere.
Where? Tell me where. Afghanistan. Okay? This guy can shoot his missile with an initial upward velocity of 200 meters per second. Okay? So there's three possibilities that can happen. Okay? He can shoot the cannon like that, right? And it can get as high as 2,100 meters twice. Do you agree with that?
Yes.
He could shoot the cannon and it could get to 2,100 meters one time. Right there. Or he could shoot the cannon. I'm sorry my parabolas aren't very parabolic. Can you just use your imagination? He could shoot the cannon and it doesn't get to 2,100 meters. Do you see that those are the three possibilities? Two real solutions, one real solution, or no real solutions. Is everybody okay with that? So here's what you're told in your worksheet. Psst. Here's a formula that we're going to use all day today. Oh, except I wrote it wrong. Can you forgive me, please? It's RT minus 5t squared. Where d is the distance above the target. We're not talking about this distance right here. We're talking about the distance above the target. You okay with that? R is the initial upward velocity. And t is time. How is it measured? Time is just seconds, right? Distance is meters, time is seconds. Okay? Can we fill out, do we have enough information to fill out this quadratic? What's the distance? What's the height of the plane? 2,100. What's the initial upward velocity? 200 t minus 5t squared.
Hey, we can solve that.
We could, but we don't want to. Okay? What I do want to do is get it into standard form, though. Okay? Standard form equals 0. So I'm going to subtract 2,100 from both sides. Oops, 2,100. And get it in standard form as I go. So negative 5t squared plus 200t minus 2,100. Everybody okay with that? I could solve and find out when it would be at the height. That's not what I want to know. I want to know, is it possible to get to that height? Because all I'm asking, I'm not even saying, will the guy hit the plane? Because that has to do with his accuracy, his aim, things like that. What I want to know is it possible for the missile to get 2,100 meters high? Is it possible to hit the plane? So all I really need to do is the discriminant of this quadratic. All I need to do is b squared minus 4ac. So in this particular problem, b is 200, right? What's a? Negative 5. And what's C? Negative 2100. So I could take the time at this point to do this all by hand, or I could just use my calculator, right? 200 squared minus 4 times negative 5 times negative 2100. So my discriminant is negative 2000. What does that mean? No what? It will not reach because the discriminant is negative, right? Do I care that it's negative 2000? No, I need to know that, right? But what I care is that it's negative 2000. So this is a discriminant, but I need to be able to write my answer. Okay? What is my answer? The missile will not reach the height of the plane? Because what? Very good. Because the discriminant's negative. This is my work. This is my discriminant. This is my answer. Does that make sense? I show my work by finding my discriminant, but this right here is my answer. This is not my answer. This helps me get my answer. Is everybody clear on that? Okay. Any questions on this? So that's one side of your worksheet. One side of it just deals with solving using the discriminant. We're not solving the quadratic. I'm not finding when will it hit the plane or when does it have the possibility of hitting the plane. I'm saying will it get to the height of the plane? Is it possible to hit the plane? We solve those by figuring out the discriminant. Okay? The other side of your worksheet talks about problem solving with quadratics. Okay? So it says something like a football is kicked into the air. You guys ever have experience with that? Have you ever had experience kicking anything into the air? We're not talking about little brothers. Okay? So a football is kicked into the air with an initial upward velocity of 25 meters per second. So if 25 meters per second is what in our formula? What is it in this formula? That's our R. So our equation that we're going to use, our quadratic we're going to use for a problem like this is 25t minus 5t squared. Then underneath it, it has like A, B, C, and D. It has different questions that you need to answer based on this equation. So we've got to come up with this equation first, right? Okay? So maybe the first question says, what is its height after 2 seconds? How high is it after 2 seconds? Well, how am I going to figure that out? So 25 times 2 minus 5 times 2 squared. So 50 minus 20. But I could do that in the calculator if I wanted, right? But 50 minus 20 is pretty easy to do. 30. 30 what? Okay. Is 30 the right answer? No. Is 30 meters the right answer? Yes. Okay. When we're doing word problems, story problems, problem solving, whatever you want to call it, we label our answers every time or they're wrong. Okay. I'm not asking you to write the height of the football after 2 seconds is 30 meters. I'm asking you to remember to put a label on your answer. Is that fair? Okay. But what is the height after 3 seconds? Oh, the same thing. Okay. So 25 times 3 minus 5 times 3 squared. 30? Wait a second. Oh, 30 meters. Okay, excellent. Oh, okay. So you're saying it doesn't go up to 30 and then go straight across and then come back down, right? That doesn't happen, right? That's bad. It goes up and comes back down. It just happens to be 30 meters right there, right? Okay, just making sure. You guys have seen a football kicked up in the air before, right? So you know it doesn't do this. Okay, so it does this, so you know it's 30 meters here and here. When is it 20 meters above the ground? Yeah, absolutely. 20 becomes my distance above the ground, right? So 20 equals 25t minus 5t squared. What am I doing this time? I'm solving for t because it's asking me when. That's a time question, isn't it? Okay, so I'm going to subtract 20 from both sides and get it into standard form. So 0 equals negative 5t squared plus 25t minus 20. Is that the only way I could do it? No, I could move everything to the left-hand side. I just chose to subtract 20. Now, this worksheet is called Problem Solving with Quadratic Functions. We sang the quadratic formula so we'd remember it. Does that mean that's what I have to use to solve this? No, absolutely not. In fact, if I factor out a negative 5, I'm left with t squared minus 5t plus 4. Guys, can't I factor that? Wouldn't that be a whole lot easier than quadratic formula? Negative 5, t minus 4, and t minus 1. If all these multiplied equals 0, don't I have to set them all equal to 0? Negative 5 equals 0, t minus 4 equals 0, t minus 1 equals 0. Does negative 5 equal 0? Whatever equals 0. Oh, so we just ignore that one. T equals 4, t equals 1. When is it 20 meters above the ground?
4 seconds and 1 second.
4 seconds.
That's not hard. Take it to 20 meters.
1 second. Yeah. I don't know. So that means if we're going back to our graph over here, then maybe 20 is right here. 20 meters. Okay. And that is time-wise 1 second and 4 seconds. Right? So then when will the ball hit the ground? What's the distance above the ground when the ball hits the ground? So 0 is our d value. So I just have to solve that. Once again, is quadratic formula the easiest way to solve this? How should I solve this one? Factor out of 5t. What am I left with if I factor out of 5t? 5t minus t? 5t minus t or just 5 minus t? 5 minus t. So I set each one of these equal to 0. What's t equal in this first one? 0. What's t equal in the second one? Try one more time. Just 5, right? Okay. So what's the answer?
At 0 seconds and 5 seconds. No.
Read the question. 5 seconds. Why isn't this an answer?
Because the ball's already on the ground.
That's when it started, right? That's where it started. That's when he kicked it. Okay? This is when it hits the ground. 5 seconds.
Maybe we should go outside and taste this.
Oh, I don't want to do that right now, but that's a good suggestion. Yeah, it's cold. Okay. Any questions about what to do on your worksheet today?